Okay, number 38, the actually doing it. Integral of x cubed plus 2x squared plus 3x minus 2 big over x squared plus 2x plus 2 squared dx. I think last time I said the first way I will do is I make it like this: x cubed plus 2x squared plus 2x plus x minus 2 over x squared plus 2x plus 2 dx. Now, what I do here is just variation. So you don't have to do it the way I do it. You don't have to do it the way I do it. This is one way. In fact, I'm planning to, I think today we have enough time, so I can do plenty of things today. So let me do two different ways of doing this problem. So at least the first one is the first three terms are factor dx. And then the last two terms, separate them. Okay, so this guy becomes x over x squared plus 2x plus 2 dx. This one here, let's see. I want to make it 2x. So if my u is 2x plus 2, I'm sorry, x squared plus 2x plus 2, then the du will be 2x plus 2. Okay, I want to get 2x plus 2 divided by 2 becomes plus 1. And then minus 3 times that. So I just keep on massaging this. You can see that 1/2, by the way, 1/2 times 2x plus 2 minus 3 is x plus 1 minus 3, which is x minus 2. Is right? So I get this thing back. Now the reason is so that, okay, so that I can change this to u here. So 1 over 2, this is du equals to 2x plus 2 dx. So this is du over u squared. Right? Okay, while the one here, I think you can do the same thing. I can do the same thing. This is 1/2 times 2x plus 2 x squared plus 2x plus 2 minus have extra 1x there, so minus, I'm sorry, I have extra 1, subtract by 1. So dx over x squared plus 2x plus 2. And the last one here, this is 3 over x squared plus 2x plus 2 squared dx. Okay, let me show you that I can confirm that 1/2 times 2x plus 2 minus 1 equals to x plus 1 minus 1, that's equals to x, the one I have here. So Thomas, what is the purpose you did it like that? Well, because this is equals to 1/2 integral du over u. The same u I have there. The same u I have here. The same u I have here. Okay, so I have 1/2 of that, and then minus integral dx. Let me complete this square here. This is x plus 1 squared plus 1 plus 1/2. I will integrate all of them at once. Du over u squared, and then this is 3 over integral 3 over x plus 1 squared plus 1 dx. Oh, with a square, like that. So this will be 1/2 ln absolute of u minus tangent inverse of x plus 1 minus 1 over u, actually 1/4, see, 1/2. What recap? You mean review? You do it yourself before class. Look at my notes, study. If I need to do recap, then that's another half an hour just to do review. And actually what I do here is basically doing review here. Minus, if I do substitution, w equals to x plus 1, dw will be just dx, right? So this will be 3 over u squared plus 1 being squared du. This is 1/2 natural log of x squared plus 2x plus 2 minus tangent inverse of x plus 1 minus 1 over 2 times x squared plus 2x plus 2, then minus, how to integrate that thing. How to integrate 3 over u squared plus, no, I should not use u there, maybe phi, because I already used u earlier. 3 over phi squared plus 1 being squared d phi. How to do that one? I think I will try integration by parts. Okay, let me try integration by parts. I'm not sure if it will work though, but I guess that's the only option for me. Oh, no, just do strict substitution. So the phi equals to tangent theta. So d phi will be secant squared theta d theta. Oh, okay, yeah, we can take the 3 out later. Okay, so this will be, now, do not detach them though. Unless you really want to do it separately, then don't make sure you don't use equal sign, and you just basically write it properly. Okay, but right now I don't detach them, so I copy the rest. So I get integral 3 over, this will be secant squared, secant to the 4th theta at the bottom, and at the top we have secant squared theta d theta. Ah, okay. So that's, notice that I did this problem without using partial fraction decomposition at all. This is minus 3 integral cosine squared theta d theta. Which is, and I need to use double angle formula, power reduction. That's 3 over 2 integral 1 plus cosine 2 theta theta. Minus 3 over 2 integral of 1 is theta. Integral of cosine 2 theta is 1/2 sine 2 theta. Don't forget plus constant. Ooh, that's a long, painful thing. Minus 3 over 2 tangent inverse phi. But what is my phi again? Is x plus 1. The tangent inverse x plus 1. Minus 3/4 sine 2 theta. Is constant. Okay, for the last part there, I know that tangent theta equals to phi, so that's actually x plus 1, right, which is phi. This is square root of x squared plus 2x plus 2. 1/2 natural log of x squared plus 2x plus 2. I will combine the tangent inverse. That would be minus 5 over 2 tangent inverse of x plus 1 minus 1 over 2 x squared plus 2x plus 2 And then minus 3 over 4 times 2 sine theta sine theta. Plus constant. Just to remind you that sine 2 theta is 2 sine theta sine theta. Final step. That's 1/2 natural log of x squared plus 2x plus 2 minus 5/2 tangent inverse x plus 1 minus 1 over 2 times x squared plus 2x plus 2 minus 3 over 2 times x plus 1 over x squared plus 2x plus 2. Oh, I can combine like terms for the last one. Huh? The last two terms. I can combine like terms and make them into one single fractional expression. I think I overdo this. But at the same time, that's minus 3x, negative 1 minus 3, that's minus 4, plus 4, 2x squared plus 2x plus constant. Now let's see if there's another way to do this. Let me copy the question now. Number 38, the second attack. Any idea? You may say partial fraction decomposition right away. Okay, let's do it. So partial fraction decomposition. Now I don't know which way is better though. Okay, I don't know which way is better. I think I have my intuition, but still, when you put it in practice, that may not be the best. I know this will be x squared plus 2x plus 2 squared. Because it's irreducible, then I will have this thing. I will have x squared plus 2x plus 2 and x squared plus 2x plus 2 squared. 1 degree less. And I multiply by the LCD, which is x squared plus 2x plus squared. That will give me x cubed plus 2x squared plus 3x minus 2 equal to ax plus b times x squared plus 2x plus 2 plus cx plus d. Oh, I think this one is easier. Maybe not. I don't know. I need to use parentheses here. I don't know. Yeah, when I look at the x cubed term, I get the coefficient on the left is 1. The coefficient on the right is only a. Correct? In fact, I can also look at the x squared term. When I look at the x squared term, on the left hand side, that's 2. On the right hand side, to get x squared, it has to be this guy and then that guy. So that will be 2a plus b. Now let me solve that. Which implies b equals to 0. And then how about the x term? You know what, I'm lazy to do it. Let me pick numbers. Let's say x equals to 0. When x equals to 0, on the left hand side I get -2. On the right hand side I get 2b plus d. So d is -2. See, when I choose x to be 0, suddenly all terms with x become 0. Right? And then when x equals to 1, let's say, on the left-hand side, I will get 4. On the right-hand side, I get a plus b times 5 plus c plus d. The a equals to 1. The b is 0. The c is unknown. The d is -2. Let me make sure I did it right. Okay, so 4 equals to 3 plus c equals to 1. In other words, then the x cubed plus 2x squared plus 3x minus 2 is over that ugly thing, is equal to x over x squared plus 2x plus 2 plus x minus 2 over x squared plus 2x plus 2 being squared. So if I apply the integral here with dx, that would be the integral here with dx, the integral here with dx. Now how to compute that, that's another story now. if I do the substitution, this will be u minus 1 over u squared plus 1 dx integral u minus 3 over u squared plus 1 squared du, not dx. And eventually you will still get what I had earlier. Because then when you break this up, this is equal to integral of u over u squared plus 1 du. That's integration by, that will be integration by substitution. Integral 1 over u squared plus 1 du, that's tangent inverse of u, plus integral of u over u squared plus 1 squared du. I will do substitution also there. Minus 3 integral of du over u squared plus 1 u squared. Then I use trigonometric substitution there. Okay, you will see this is 1/2 natural log of absolute of u. I'm sorry, absolute of u squared plus 1. Minus, this is tangent inverse of u. Plus, if I do another u sub, this is 1/2 integral of w squared dw, where w equals to u squared plus 1. Minus 3 times if u equals to tangent theta. So I will still get the same thing. I will still get the same thing. Okay, of course, at the end, you need to bring all the variables back to u though. Okay, you will still get everything back to u. Oh, I wonder if there's another way to do this. I think the second way is more efficient than the first one. Yeah, the first one I keep on modifying here and there just to catch a nice shape. But you see at the end, I get this part here, right? The same with this, right? And this guy is basically here, right? Okay, and this guy will be the integral of this. And so on and so forth. Why that one is plus and this one is minus? Hold on. Something not the same. Something not the same. I know there's a message coming in, but I need to check this first. Why is this minus here? Oh yeah, it comes from this. So when I integrate this later on, I get negative part. That would be will be negative 1 over 2W. Okay, still same result. Let me see the message now. Can you show the first result again? I can, which is very long, I know. So which part you want me to show you? You know, I will save this into PDF and put it in the discussion board, right? I somehow think there must be a better way to do this. I just don't know what's that. I just don't know what's that. Yeah, but with some experience, then you kind of have. So when the question is that complicated, the only way you can really do it is by just do whatever you can. Okay, but of course, at one point, you need to realize this thing though. Even though I say you do whatever you can, keep in mind that what you try to do is what we call divide and conquer. Divide and conquer means the further you go, even though you cannot solve that in full, at least you break it into simpler form. This is simpler than the original one, right? This is simpler. This is simpler. You see? Okay. So if let's say you cannot do this, at least you know how to do this part, then you're fine, right? Okay. At least you know that this is the part you cannot do. Okay. What you don't want to happen is like the further you do it, the more complicated it is. Nah, then that's not what you want. Let me see what I have to do. Let's see. Erase this early. Okay. Let me go on. Let me go on to the later part. Number 40 and on. Between number 40 to number 50, choose 2 or 3 questions you want me to do. I give you 10 seconds, you choose it. Okay, then I will do only 2 problems. I choose number 42. Right? Somebody said number 42 also, and 46. Number 46. Let me see. Number 42, integral from 0 to 1 of 1 over 1 plus square root of 3 times cube root of x dx. I do substitution. Let u equals to cube root of x. So u cube is x. 3u squared du equals to dx. So the integral now becomes 1 over 1 plus u, 3u squared du. And then when x equals to 1, when x equals 0, the u is 0. When x is 1, the u is 1. So the limit of integrations happens to be the same. Now notice that now we have improper integral, improper rational functions, rational integral. You notice that? Then I will divide it, and that happens to be a polynomial, right? Use synthetic diffusion. You can do it long diffusion. Go ahead. I will use synthetic diffusion. Comments, I don't remember synthetic diffusion. Then go back to your pre-calculus teacher, ask him or her. I just tell you that's synthetic diffusion. If you don't remember, you go to YouTube, let's say, but worse in worse, you go back to your teacher and ask. So this is integral from 0 to 1 of 3u minus 3 plus 3 over 1 plus u du. That is 3 over 2u squared minus 3u plus 3 natural log of 1 plus u, all of them from 0 to 1. So the first group, 3 over 2, when u equals to 1, when u equals to 0, that's the 0. That's 0 plus 0 plus 3 ln 1, which is 0, right? 0. So we will get negative 3 over 2 plus 3. That's for number, that's for number 42. Actually, you can massage this a little bit. Another way to look at this, I try to be evil right now. This is 3u squared over 1 plus u, right? Okay, let me make it plus u and then 3u squared, the u squared, and then I minus u. But when I minus u, I want to make it u plus 1. So I plus 1 here, I plus 1. How do you get that times? How do you get that? So how do you play with u squared such that you can make it in terms of u plus 1? So the way I see is this. This is u times u plus 1. Okay, but that will give you u squared plus u, so I subtract by u to compensate that. But I want to change this in terms of u plus 1 also. So I make it u plus 1 here, right? But it means negative u minus 1, add 1. Notice that I basically divided. So this is equals to 3 integral from 0 to 1, u times u plus 1 over u plus 1 minus 1 plus 1 over 1 plus u. But again, that's a lot of, this is just u, right? So this is 3 parentheses 1/2 u squared minus u plus 1 over, sorry, not 1 over, that's ln, plus ln of u plus 1 from 0 to 1. and you will get the same result, I believe. Now, the way I did in black here is more systematic way to do it. Okay, actually, yes, if I factor the 3 out, it will be a lot easier. Right? Okay, you can also divide using long division instead. So 3u squared plus 0u plus 0 divided by u plus 1. That's 3u for 3u squared plus 2. And then subtract, I get negative 3u plus 0 plus minus 3. Okay, so that's what happened from here. Either you use syntactic division because the denominator is x minus something, x minus c form. So you take a look on syntactic division, or if you use long division, you will still get the same thing here. That's for number 42. Number 46. Integral of square root of 1 plus square root of x over x dx. Now, one of the weaknesses that a lot of students have is when they see a problem, okay, you try to look for a shortcut. Sometimes you just need to go on with your intuition first. Now, in this question here, what is the difficult part? What makes it seems to be not doable? I think it's this one. Right? Okay, so if I call that u, then u squared equals to x, 2u du equals to dx. Right? So now the integral becomes square root of 1 plus u over u squared 2u du. Right? Staring at that will not give you the answer. Right? Do something. Okay? Do something. Instead of just thinking about what should I do, and then you start imagining things. No, it doesn't work that way. No, do something. Okay, when students ask me questions, especially at this level and on, what I tend to ask them back first is what you have done. Let me see what you have. And I encounter a plenty of students who had this. Thomas, I don't know what to do. I say, why don't you do this? And they say, but what if? But what if? Do it first. Okay, if you don't write it down, you don't see it. Okay, then what next? What next from here? What next from here? Let me substitute again. W equals to u plus 1. What do you think? Right, so dw equals to du. With that substitution, then I get 2 integral w to the power of 1/2 over actually no. Let me make it square root right away. I can just do it that way, but let me just do square root right away. So w equals to square root of 1 plus u. So w squared minus 1 equals to u. 2w dw equals to d. Integral, this is w here. The u will be w squared minus 1. And then du will becomes 2 w d. So I get 4 integral w squared over w squared plus 1 dw. Let me make it like this, minus 1 plus 1. So this is equal to 4 integral of 1 plus 1 over w squared plus 2. Which will give me 4 times w plus 4w plus integral 1 over w squared plus dw. At least I finished one of them. Okay. And then, any idea how would you do this one here? Trig substitution? Actually, I don't think so. I don't think that's what you want to do. Okay. Supposed to be, no, it's not ln because this is factorable. So then you will end up with partial fraction decomposition thing. It's integral something over w minus 1, something over w minus 1 dw. Okay, there will be 1/2 here. Okay, you do your partial fraction decomposition yourself. This is 1/2 here, that's another 1/2. Okay, then I get 4w plus 1/2 natural log of w minus 1 plus 1/2 natural log of w plus 1 Oh no, I'm sorry, it's not. It should be minus here, minus 1/2 here. It should be minus 1/2 here. Yeah, I tried to do it fast. I'm sorry. I tried to do it fast. So what is my w again? It's 4 square root of 1 plus u. I think it's plus c. But actually the last part here, the last part there can, I think we can simplify that a bit. Maybe, maybe not. I'm not sure. Let's see. Suppose I multiply by the conjugate. Suppose I multiply by the conjugate of the denominator. Then at the bottom, I will get 1 plus square root of x minus 1, while on the top I get square root of 1 plus square root of x minus 1 being squared. So it is possible that in your textbook you will see something looks like this. This is 1/2 natural log of square root of 1 plus square root of x minus 1 squared over square root of x plus c and then I will split the log, but this then becomes square ln of square root of 1 plus square root of x minus 1 minus 1/4 natural log of absolute of x plus c. It is possible that's what you get. Should the 4 be distributed? Maybe you're right. Let's take a look. You're right, I should distribute that 4. I should distribute that 4. Move it here. Comes 3 and then 2. So this is 4 here and this is. Thank you. The one interesting is actually number 45. Number 45. I will not do this in full. I will not do this in full. I give you the idea. They give you the hint there, square root of x minus cube root of x dx. The hint is, they say u equals to square root of the 6th root of x. The question is why? Suppose I don't give you that hint. Can you come up with that hint yourself? Why? Well, the reason is because square root of x is x to the 1/2, which is you can rewrite it as 3/6, right? And then cube root of x is x to the power of 1/3, which is x to the 2/6. Okay, so if you see x to the power of 1/6 as the u, that will be x cubed for the top and x cubed for, u cubed and then u squared. That's the hint. Okay, so if your u equals to the 6th root of x, it means u to the 6th equals to x, 6u to the 5th du equals to dx. Okay, and then the integral now becomes integral 1 over u cubed minus u squared, 6u to the 5th u. Okay, you can cancel 2 of the u's. Okay, and then from there you divide, right? You need to divide because that's improper. And then so on. I want to develop a formula which is actually in our textbook at the back of our book, but we see this quite a lot. Suppose I have the integral of dx over x minus a, x minus b. And let's say, just for sake of simplicity, a is less than b. How do we integrate this? Yeah, because if we can do this fast here, then you can do this problem a lot faster, because this is 1 over W minus 1, W plus 1, right? Now what I'm trying to do is to find a formula to integrate that. Okay? So by partial fraction decomposition, we get 1 over x minus a, x minus b equals to a over x minus a plus b over x minus b. Of course, you know the capital A and lowercase a are not the same here. Find by the LCD. We get 1 equals to a times x minus b plus b times x minus a. And use special value when x equals to a, you get 1 equals to a times a minus b. So a is equals to 1 over a minus b. When x equals to b, then 1 equals to b times b minus a. So b is equal to 1 over b minus a. Now remember that a is smaller than b, right? So I can write this as 1 over b, negative 1 over b minus a. In short, then, integral of dx over x minus a, x minus b is equals to the integral of negative 1 over b minus a of x minus a plus 1 over b minus a over x minus b dx. Or if I factor that 1 over b minus a, I get integral 1 over x minus b minus 1 over x minus a. This will be natural log of x minus b minus natural log of x minus a. It's constant. This is equal to 1 over b minus a of natural log x minus b over x minus a plus constant. Okay, again, if the b is greater than a. So then how do I apply that to what happens if I have integral of the one we have earlier, w minus 1, w plus 1. This is 1, and this is negative 1. The big minus small, okay, big minus small, big minus small. So that would be 1 over big minus small, natural log of x minus big over x minus small. Oops, should be w. Now, if possible, memorize this. Okay, if possible, memorize this. Otherwise, it will take you too much time if you need to redo it again. Now, then if I go back to number 14, by the way, if I go back to number 14, we have that integral of 1 over x plus a, x plus b dx. Now, they don't tell us which is greater, which is smaller. And actually, it actually doesn't matter which is bigger, which is smaller. Okay, as long as you see this as x minus negative a for the first part, right? And x minus negative b for the second part. If you see it that way, then you still get what you need. Okay, so that will be 1 over, let me replace the b by negative b and a by negative a. So I will get 1 over a minus b, natural log of x plus b over x plus a. Of course, if you do it long way, you will get the same thing. Okay, if you do it long way, you will still get the same thing. Well, because of this though, I want you to realize that this thing here actually is the same to 1 over b minus a, natural log of x plus a over x plus b. It's the same. Why? Because when you do the reciprocal, you get the opposite. Right? Natural log of x over y is equals to negative natural log of y over x. I hope you realize that. Now that negative that you get from reversing the order here, the negative you get from reversing order here, when you reverse that you get negative, right? But that negative is being reversed again because you reverse the order of subtraction. So it's some algebra there, okay? Some algebra there. Now, why I want to do that? Because then that helps us to do more problems a lot faster. Let's say, for example, I do number 50, maybe, or maybe 50 or 48 first. Number 48. Number 48, integral of sine x over cosine squared x minus 3 cosine x dx. If my u equals to cosine x, then my du will be negative sine x dx. So this becomes integral of negative du over u squared minus 3u. Is that right? Then we say it this way. This is negative integral du over u times u minus 3. Are you with me? That's equals to, now, this is u minus 0, and another one is u minus 3, right? So this will be 1 over, oops, that would be 1 over 3 minus 0, natural log, u minus 0 over u minus 3. Is it right? Let's see. Oh, the big one on the top. Okay. It's u minus. So that's constant, so that's negative 1/3 natural log of cosine x minus 3 over cosine x plus constant. Otherwise, you need to do the partial fraction decomposition again. Number 50. Well, I end up doing so many problems here. Integral of e to the x over e to the x minus 2 e to the 2x plus 1 dx. If my u is e to the x, my du will be e to the x dx. So this is equal to du over u minus 1 u squared plus 1. And then I do partial fraction decomposition. 1 over u minus 1 u squared plus 1 will be something over u minus 1, and then bu plus c u squared plus 1. Oh yeah, thank you, u minus 2. And then multiply by the LCD. I get 1 equals to a times u squared plus 1 plus du plus c times u minus 2. Then let me use u equals to 2 first. When u equals to 2, I will get 5a. Therefore, a equals to 3. Now what happens when u equals to 0? That's a plus, actually, when u equals to 0 minus 2c. So 1 equals to 1/5 minus 2c. So 2c equals to negative 4/5. C equals to negative 2/5. Then how do I get the b's? Okay, let's say u equals to 1. Actually, I don't need to. When I look at the u squared term, on the left hand side the u squared term is 0, on the right hand side the u squared term is a plus b. Right? Therefore, from there, b must be negative 1/5. Okay, then we have that integral of du over u minus 2 u squared plus 1 is equals to integral 1/5 over u minus 2 minus 1/5 u plus 2/5 over u squared plus 1 du. I factor the negative out. Is it easy? I factor the negative. So this is equals to 1/5 natural log of u minus 2 minus 1/5 integral of u plus 2 over u squared plus 1. That would be integration. You need to split it. Okay, that one you need to split it. So 1/5 natural log of u minus 2 minus 1/5 times 1/2 natural log of absolute u squared plus 1 minus 2/5 tangent inverse of u plus constant. Now I substitute that e to the x back. Okay, let me give myself some little break. Right now it's 8:33. We come back at 8:43. Now let me ask you to take a look at the book. Pick questions you want me to do. I don't promise you that I know how to do it, but at least I think it should be okay. Anybody? Let's say, to make it easy for us, between number 2 to number 20, choose 3 questions. And then number 22 to number 40, choose 3 questions again. And then number 42 to number 60, choose 3 questions again. And then 62 to 82, choose 3. So there are 12 questions. Can I do that in 1 hour? Okay, let me see what you have. 1 second. Number 12. 9. Why you choose even numbers? 9, 16, 22, 27. Okay, let me do this first, then 30. Let me do whatever we have first, number 9. Integral from 1 to 3 r to the 4th ln r dr. I don't know how to integrate ln r, but I know the derivative. Let me rewrite it. It's integral from 1 to 3 of ln r to the 4th dr. Do integration by parts. That's 1 over r, that's 1/5 r to the 5th. So this is equal to 1/5 ln 1/5 r to the 5th ln r from 1 to 3 minus integral 1/5 r to the 4th dr from 1. So this is 1/5, 81 times 3, 243, ln 3. ln 1 is 0, so I will just ignore it. So this is 1 over 25 r to the 5th from 1 to 2. So 243 over 5 ln 3 minus 1 over 25. 3 to the 5th is 243 minus 1 is 242. That's for number 9. Number 12. Let me read here. No, that's the space for later questions. Number 12. Integral of x over x to the 4th plus x squared plus 1 dx. So I think I will do substitution where the x squared is equal to u equals to x squared, du equals to 2x dx. So this becomes 1/2 du over u squared plus u plus 1. Okay, this is equals to 1/2 integral du. I will complete the square at bottom as u plus 1/2 squared plus 3/4. Okay, so this is equals to 1/2, and then square root of the reciprocal of this. I wonder if you remember square root of the reciprocal of that. That will be square root of 4 over 3. I will simplify that later on. Okay, and then tangent inverse of u plus 1/2 over square root of 3 over 2 plus constant. That's 1 over radical 3 tangent inverse multiply by 2 at the top and the bottom. I get 2x squared plus 1 over squared. So you see it would be nice if you memorize that formula. If you memorize this integral of dx over x squared plus a squared. That's equals to 1 over a, the reciprocal, tangent inverse of x over a plus constant. Right? It will be nice if you memorize that. Next, number 16. Integral from 0 to square root of 2 over 2 of x squared over square root of 1 minus x dx. I think this one we need to do trig substitution. So x equals to sine theta. So dx equals to cosine x cosine theta d theta. Then I need to refer, also change the limit of integration here. So this is pi over 4, this is 0, right? Sine squared here, theta over the denominator will be cosine theta. And then dx will be cosine theta d theta. This is equal to cosine theta change, just 1/2 integral 0 to pi over 4, 1 minus cosine theta d theta. Sine squared. Okay, so sine squared becomes 1 minus cosine 2 theta over 2. And then when I integrate that, I get theta minus 1/2 sine 2 theta. from 0 to pi over 4. So you see, I don't need to change it back to I don't need to change it back to x anymore. Right? This is pi over 4 minus 1 half times 1. When theta is 0, both of them 0. So this is pi over 8 minus pi over. I'm sorry, pi over 8 minus 1/4. That's for number 16. Number 22. I know it gets harder. So that's why for the earlier one, I will try to do it faster. Number 22. What the function? Natural log of x. Am I recording this? Okay, good. Integral of natural log of x over square root of x square root of 1 plus ln x squared dx. This is clearly substitution. U equals to ln x, right? So du is 1 over x dx, right? This is my one. This will be my u, my du, right? That's integral of u over square root of 1 plus u squared du. Okay, then let w equals to 1 plus u squared. That's 1 half integral w of negative 1 half d w. That will be w of 1 half plus constant 1 plus natural log of x being squared of is not x to the power 1 square root. Maybe I prefer to write it this way. The square root of 1 plus square root plus constant. That's number 22. Number 27. Integral of dx over 1 plus e to the x. Ooh, that's hard. How to do this? Let's say u equals e to the x, or du e to the x dx. Let's do some modification first. This is e to the x dx over e to the x times 1 plus e to the x. How about that? So basically, I multiply the top and the bottom by e to the x. Now then, on the top, that becomes my du. At the bottom, then I get u times u plus 1. Okay, this is u minus 0. This is u minus negative 1. So is this section just a review of the all previous section? That's true. What we do here is just review of everything we learned about technique of integration. Okay, so this is 1 over big minus small natural log of over minus 1. I think the small one at the top. Let me see. I think the small one at the top. We developed somewhere. So this should be u plus 1 here. But that's basically 1. So this is ln u plus 1 over u plus constant. Oh, it's the other way around, huh? It's the other way around, my bad. So I was right first place. Well, because 1 over u times u plus 1 is equals to 1 over u minus 1 over u plus 1. Right, so when you integrate that, there will be ln absolute u minus ln absolute u plus 1. So yeah, I was right first place. Can we do trig substitution for the last one? Which one is the last one? Here. Number 22. 27. I don't see you can do any trig substitution. For the last one, you mean here? There's no way for you to do trig substitution there. You can, don't get me wrong, you can, but I think it's, you're working too hard. You will be working too hard, okay? But let me do it anyway. Okay. Let me do it anyway. So let me code it from there. This is integral of the u over u squared plus u. Now I will modify this by completing the square. This is u plus 1/2 squared minus 1/4. So basically it becomes integral of dw over w squared minus 1/4. W is u plus 1/2. Now from here, this is, well, I'm still not doing, I'm sorry, I'm still not doing trig substitution though. I'm still doing just this. Which we know that will be 1 over big minus small natural log of w minus big over w plus minus small. So this is 1 natural log. That's u over plus 1. What is my u again? Oh, I still need to change it back. I'm sorry. This is natural log of e to the x over e x plus 1. Okay. It's not the final answer. In fact, I can go further here. This is x minus natural log of e to the x plus 1, which is always positive anyway, so let me just use parentheses. There is constant. Likewise here. Now, the thing is, if you want to do substitution here, let's see. Why does it is an x absolute of x? Which one? For this part here? Because natural log of absolute of e to the x, e to the x is always positive anyway. Okay, and natural log of absolute e to the x plus 1, e to the x plus 1 is always positive anyway, so I don't need to use absolute sign. I mean, you can, okay, but don't need to. Anyway, I want to experiment with a substitution there. So integral dw over w squared minus 1/4. Suppose my w is secant 1/2 secant theta. So dw will be 1/2 secant theta tangent theta d theta. And at the bottom, that will be 1/4 tangent squared theta. This is 2 integral. We have secant theta on the top over tangent theta at the bottom. Simplify 1/, so this will be integral of cosecant theta d theta. Integrals cosecant theta d theta, I think that's negative natural log of cosecant theta plus cotangent theta. But let me check. I question myself. Or cosecant minus. So no negative here, but it's negative. And then I go back. Secant theta equals to 2w this is w over 1/2. So what is cosecant theta? Cosecant theta will be w over square root of w squared 1/4 minus cotangent. That will be 1/2 over square root of w squared minus 1/4 plus constant. That will be 2 natural log of w minus 1/2 minus 2 natural log of absolute square root of, and then I don't need absolute anymore. Oh, I do it anyway. What's my time? 1/2 secant. ln the 1/2 cancels, so this will be natural log of w squared minus u squared. W is u plus 1/2. I change it back to theta, but still. There's my u again. 8x. This is 2x minus, notice that here I can factor a u out. Supposed to be with absolute. X minus natural log of e to the x plus 1 plus constant. This is what I can do. Let's do that again. So to answer your question, can we use trig substitution? Yes. Do we have to use trig substitution? No. Number 3. I like number 3. Integral from -1 to 2 of absolute e to the x minus 1 dx. Now we need to find at what x e to the x minus 1 equals to 0 and becomes negative. Okay, basically you want to do the sine graph of e to the x. Sine graph of e to the x minus 1. So step 1, the critical numbers. That's e to the x minus 1 equals to 0, e to the x equals to 1, x equals to 0. Sine graph. When x is greater than 0, then this is positive, less than this is negative. In other words, e to the x minus 1 is greater equals to 0 when x is greater equals to 0, and it is negative when x is less than 0. Now, why do we need that? Because then you see that the guy here is positive all the time, right? It's inside the absolute. Okay, so if I want to get rid of the absolute sign, I need to split them first on the region where it will be negative and the region where it will stay positive. Okay, this is negative integral from -1 to 0 of e to the x minus 1 dx plus integral from 0 to 2 of e to the x minus 1 dx. When x equals to 0, that's 1 minus 0. When x is -1, it's minus e to the minus 1. I'm sorry. Yeah. Plus 1 equals to 2, that's e squared equals 2, and e equals to 0, that's 1. So this will be negative e to the, I'm sorry, that's positive. That's positive e to the, it's supposed to be positive there. I mean, this is the integral of, this is an integral of a positive value. So the result is supposed to be positive. That should not be negative. Okay, and then plus e squared. Yeah, but the key steps here, you need to separate the integral into two parts that is positive, because the integrand is positive. Okay, go back to our list. Choose 6 more questions. Maybe 3 questions first, between number 42 to 60. Number 42. Anything else? Maybe one more. I know in 30 minutes I can do at least 2. Okay, while waiting, let's do that number 42 then. Integral of tangent inverse of x over x squared dx. I don't think I can integrate tangent inverse. So let me rewrite it into tangent inverse, which I will do integration by parts later on anyway. The derivative, and this is 1 over x squared dx. The derivative of tangent inverse x is 1 over 1 plus x squared. The integral of 1 over x squared is negative 1 over x. So this is equal to negative 1 over x tangent inverse of x minus integral negative of 1 over x times 1 over 1 plus x squared dx. This is tangent negative of tangent inverse of x over x plus integral 1 over x times 1 plus x squared dx. Now the one here, I will do partial fraction decomposition. 1 over x times x squared plus 1 must look like 1a over x plus bx plus c over x squared plus 1. Long time no see. So this becomes 1 equals to a times x squared plus 1 plus x times bx c. Actually, if I distribute, then it can be seen a lot clearer that the a equals to 1. A equals to 1 from the constant point of view. Right? And then for the x term point of view, c equals to 0. Right? For x squared term, that's 0 equals to a plus b, therefore d is 1. Okay, so 1 over x times x squared plus 1 is equal to 1 over x plus, I'm sorry, minus x over x squared plus 1. Okay, let me just do the integral again. This will be natural log of absolute x minus 1 half natural log of x squared plus 1 plus constant. But the one inside this last absolute value is always positive anyway. But I'm not done because this is actually part of the larger integral. So integral of tangent inverse of x over x squared dx is equal to negative of tangent inverse of x over x. Yeah, that's correct. Plus natural log of absolute of x minus 1 half natural log of, I don't need absolute value anymore because x squared plus 1 always positive. That's for number, what number? Which question did I do? Number 42. I wonder about how would you do number 32. It's just substitution, I believe. Let's see, number 32. I chose that. Number 32. I think I will do partially. I will not do all in full. Like the whole thing until the end. I'll see. That's square root of 2x minus 1 over 2x plus dx. How do you think we will approach this? I think I will say u equals to square root of 2x minus 1 such that u squared plus 1 equals to 2x. Right? So 2u du equals to 2 dx. Or u du equals to 2 dx. Then this integral becomes, this is u over 2x plus 3 is 2u squared plus 1 plus 3. Dx will be u. So this is integral of u squared over u plus 4 du. Let me manipulate this plus 4 minus 4. You can also divide it. You will get the same. Okay, so you will get this is equal to integral of 1 minus 4 over u squared plus. That's u minus tan 4 times 1/2 tangent inverse u over 2 plus constant. Oh, I finished it. Okay, any else after number 42? I'm waiting. Number 46. Integral of x minus 1 of e to the x over x dx. Oh. Oh, I have x squared. I'm sorry about it. That's the one make it hard. I wonder how to do this one. Let's see. This is equal to integral of, I will distribute. Okay, so I will get x e to the x minus e to the x over x squared dx, which is integral of 1 over x e to the x minus 1 over x squared e to the x dx. Okay, which is equal to integral of e to the negative 1 e to the x dx minus integral e to the negative, x to the negative 2 dx dx. Integration by parts for the first one. So the first one is x to the negative 1 e to the x minus integral negative x to the negative 2 e to the x dx minus the integral x to the negative 2 e to x dx. Oh, you know what? It turns out to be very nice. E to the x over x plus integral e to the negative e to the x minus, so you see the last two terms cancel. So this is e to the x over x plus constant. Step number 46. Okay, one more question from there. Nobody say anything. Oh, somebody say something. Number 59. Number 59. I will not choose even odd numbers, but okay, let's do it. Integral of cosine x cosine cube of sine x dx. You get intimidated with that cosine too much. Okay, let u equals to sine x. So du equals to cosine x. So this will be my du. This will be my du. Okay, so this is integral cosine cube u du. Long time no see. This is integral of cosine squared u times cosine u du. I will change this cosine u becomes 1 minus sine squared u cosine u du. So if my w equals to sine u, then dw will be cosine u. Integral 1 minus w squared dw. That's w minus 1/3 w cubed plus constant. What's my u again? Sine. So this is w is sine u, but u is sine x, isn't it? Minus 1/3 w is sine. W is sine x. No, that one is not scary. I look at number 48 and it scares me a bit. Let me do number. So the one I circle is the one I chose. But I look at that, honestly, I was like, oh wow, that's quite interesting. Integral from 0 to 1 x square root of 2 minus square root of 1 minus x squared dx. Let's say u equals to 1 minus x squared. So du will be 2x dx. Yeah, I want to get this to be my du, part of my du. Okay, so that will be integral. And u equals to 0, that's 1. U equals to 1, that's 0. So negative, this becomes 1, this becomes 0, square root of 2 minus square root of u, du of n2. This is 1/2 integral from 0 to 1, square root of 2 minus square root of u. Now what? Let w equals to square root of u, w squared equals to w. I flip the order of integration. The negative disappear because I flip this back. Right? Okay. I reverse the order of integration. The limits of the integration. So 2 WD, W equals to D. And yeah, W0 it's still 0. W1 is still 1. It's still 0, 1. Square root of 2 minus W times 2W D. Oh, this one is correct. So let's V equals to 2 minus, so dV equals to negative dW. Integral, this is 2, this is 1. And this becomes V to the power of 1/2. The 2 cancel. This 2 here cancel with that 1. While the W becomes V 2 minus V. And then the dW becomes negative. Okay, I absorb the negative by reversing the order of integration again. But then I will distribute this 2 V to the 1/2 minus V. See, a lot easier now. Then when I integrate, okay, this 4/3 V to the 3/2 minus 2/5 V to the 5/2 from 1 to 2. Four over 3 is 2 rather 2 minus 4, 2 over 5, 4 rather 2 minus, so this one is just the coefficient base. That is 20 minus 6, 14. Square root of 2. Yeah, it looks scary, but seems like all it does is substitution, substitution, substitution. Ooh, a lot of substitution. Okay. Maybe we do one more problem from this part here, or one more problem from 62 to 83. Or any problem, the one that you see scary, go for it. Okay, nobody say anything. Let's go home. Suggested homework from here. Suggested homework from here, from number, should we do number 1? No. Number 2, okay, number 3. From number 3 to number 59. On Monday, we will continue a little bit from here. We'll do harder problems. Let's say on Monday, the first 1 hour, maybe we do most of the even numbers here. Okay, and then on Wednesday next week, don't forget you have a test. Okay, yeah, the test is on Wednesday, and the material for your test 1, is from So chapter 6, maybe I write down, because I remember I skipped one section. Test 1 will be 6.1 to 6.6, and then 6.8, 7.1 to 7.3. A total of 10 sections. Okay. Any other question?